Hello, let's take the important chapter of your NDA syllabus. That is, the chapter name is actually Arithmetic Progression. Then later on, we'll be going to take Geometric Progression. But before going for this, we should know what is exactly a sequence, because these two topics are coming into this category only. So first, we should know about the word sequence. Sequence, as we know, we use in general English. We are having a sequence of books and something like that. But when we say sequence in mathematics, it means collection of numbers which are having some identified first term, identified second term, identified third term. Say for example, if I am going to take numbers like I am having one number and a number 2 which I am fixing, that is the first number is given to you as 1, second number is given to you as 2. Now, third number I am writing 3, then I am writing 5, then I am writing 8, then after that I am writing 13. So, when we are writing these numbers, you can see after writing the first two number and seeing the third number, you are developing some logic. That means the next number is not coming off by own, but they are having some identified logic behind that. That logic for this particular third number is, it is addition of the previous two numbers. If you see the next one 5, it is sum of, like for 3, it is a sum of 1 and 2. If I go for 5, it is sum of 2 and 3. If I go with 8, it is 3 and 5. Then subsequently, I am continuing with this one, we will be going to get the next term. So, such type of collection of numbers, we say it as a sequence. Now, when we go for a sequence in which there is a specific pattern, whenever a specific pattern is there, we say it is known as a progression. So, we will be going to take few progressions here, that is, I will be going to take arithmetic progression in the coming class and geometric progression. So, there is a difference between a sequence and the subsequent part of that one. Means the sequence in which there is a specific pattern is known as a progression. The first progression that I am going to take, in which you can see that I am having a number 5, then I am writing here 8, then after that I am writing 11, then after that I am writing 14. So, such type of progression means we are having a specific pattern. The pattern is, we are going to add 3. Again we are adding 3 to this. Again we are adding 3 to this. In the same way, if I say I am having 2, I am writing here 4, then 8, then 16, then 32. So, there is again a specific pattern, and that specific pattern is, we are multiplying 2, we are multiplying 2, and again we are multiplying 2 and multiplying 2. So, such type of specific pattern will change the name from sequence to progression. So, the first progression that I will be going to take is arithmetic progression. So, let us take a progression which is arithmetic progression. The progression means where a sequence is having a specific pattern. The pattern here that we are talking about is adding a number to a given number. Continuously we are going to add that number. That means if I take any two consecutive terms, say for example, if the terms are A1, A2, A3, A4, like that, if I am having a sequence, and then this sequence will be called as an arithmetic progression. If I see the difference of any two consecutive terms, means from the second term, if I subtract the first term, from the third term I am subtracting the second term, from fourth term I am subtracting the third term. If we see that all these differences are same, then we say that this particular progression is known as arithmetic progression. We can also say this one as term 1 and term 2. So, that is the other way of writing that one. So, that is why it is written that when the difference, that is Tn minus 1, means any term. If I take n is equal to 2, so if I take n is equal to 4, so I will be going to get an T4 minus, it is 4 minus 1, 3. That means from any term, if I subtract the previous term, then if that particular distance or the difference is common, then we say if it is having same number. Say for example, if this difference is coming as 2 and 2 and 2, we will be going to say that this particular progression is known as arithmetic progression, and that is known as a common difference. As we are finding out the difference, it is known as common difference. So, if I conclude this one, that means if we write it as A1, A2, A3, A4, if it is an AP, then the difference, that is A2 minus A1, this will be known as D, which is called as common difference. Common difference. Clear? So, common difference will be same because the word we have already used common. So, it will be third term minus second, or fourth minus third, or if you take like that 10th term, if I take A10, from 10th term I will be subtracting the 9th term. If all these differences are same, it is known as a common difference, and if we are having a common difference, that will be called as an arithmetic progression. So, arithmetic progression, now we have to find the logic to get any term of an arithmetic progression. Say, if I say that A1, A2, A3, so on, up to any number of terms, and let us find that if it is an AP, then what is the difference? We have already studied, it is having a difference which is common to all, means if I read the same thing in the other way, that we are adding a specific number to a given number. So, if I say that the first number I am fixing it as A and continuously I am adding a number to this. Let's say for example, if I am adding D to this one, I will be going to get A plus D, then again D is added, it becomes A plus 2D. So, what you can see, the second term will be going to have 1D, the third term is going to have 2Ds. In the same way, if I write the fourth term, so definitely fourth term will be going to be written as, in that 2D, one more D is added. So, we will be going to get A plus 3D. So, what logic we can see, when we are having the second term, we are having only 1D, and when we are taking the third term, it is having 2Ds. In the same way, if I develop the logic that what will be for the 10th term, so we can write in A, we will be going to have how many Ds? 9 Ds, means it is 1 less than the position. So, we are having 9D. In the same way, if I ask you what will be the 18th term, I will be going to write A plus 17D. In the same way, if we develop what will be the nth term, it will be A plus 1 less than the position. So, what is the position? N. It will be 1 less than that. So, we are having a formula for nth term as A plus n minus 1D. It is also represented as Tn. T stands for the term. So, formula is same, A plus n minus 1D. Now, we have already taken the nth term, the formula for nth term. That means the nth term of an AP, that is An, is written as A plus n minus 1D. So, let us take one example in which this formula will be used. Say if I am having a sequence, I am not using the word AP. So, if I am having a sequence like 3, it is 8, 13, 18 and so on. So, first of all, when they are saying that it is a sequence, so first we have to identify whether it is an AP or not. So, we will be going to find the difference, and if you can see the difference, 8 minus 3, it is coming 5. From 13 minus 8, we are getting 5. 18 minus 13, we are getting 5. As we can see that the difference is coming same, so we can say it is an AP. Now, the formula is applicable. Now, suppose if I want you to find, that is, find say 16th term. So, when we say about 16th term means, I am writing here A16, that is also spelled as 16th term. So, how to use this formula? After getting the confirmation that it is an AP, we will be going to say, let the first term, now here the first term will be 3 and this is already written as 8. The common difference, what difference we were getting? We were getting 5, clear? So, common difference is 5. Now, if I want to find 16th term, according to this formula, I will be going to say the 16th term will be going to have 15 D's. How we are saying that 15 D's? It is 16 minus 1. So, A plus 16 minus 1 D will give you 3 plus 15 times common difference is 5, which is 3 plus this is 75, and your answer is 78. Clear? So, this is how we are going to apply this particular formula for the nth term. So, now after understanding the nth term, we are having again very important topic of arithmetic progression, in which we are going to find the pth term from the end. So, there are two type of logics that we use in this one. So, for an example, if I take, we are having 10 fingers, clear, and in that 10 fingers, if I say what is the second finger from the end. So, if I count from this side, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are there. Second term from the end, it is this particular finger, which is actually having 5, 6, 7, 8, 9th position. So, if I just go for the position, it is 9 and 2, 9, 2 means 11. So, in that case, when we want to find the pth term from the end and we are counting from the front, so we will be going to say it will be n minus p. As we have done for 10 fingers, it is 10 minus 2. We want to find the second term from the end, but it is having one more position than that. So, this is the term from the beginning. Means, if I want to find, we can say pth term from end is nothing but it is n minus p plus 1th term from beginning. Clear? So, what we can say here, it is n minus p plus 1th term from the beginning. Now, let me tell you, dear students, it is no need to find that position from the front. So, when we are going to, when the question is going to come like that, we have to find the pth term from the end, it will be better if we go to the end term first. So, if I see the arithmetic progression from behind, the last term becomes the first term. The common difference which is there, it will be having the reverse sign. That means, if D is positive from front, that is the beginning to the end part, and if I count from the reverse order, that means D will be going to have as minus D. So, to find this one, that is to find the pth term from the end, what we will be going to do as a short trick, we will be going to take the last term as the first term and common difference will be taken as minus D. So, we will be going to take the question for this one. Now, after understanding the pth term from the end, let me take one example so that we can understand that one. So, I am taking a very simple arithmetic progression like 10, 15, 20, 25 and so on. Let me take up to 105. So, we are having an arithmetic progression in front of you where we can see that the first term is 10, the common difference that we are giving. So, here I am taking from the beginning. Clear? Now, if I take from the beginning, the first term it is looking as 10, it is already written, and if you see the common difference, this is 15 minus 10 which is equal to 5. Now, here I am asking you a question, what is the third term from the end? If I first use the basic concept that we have studied, we want to find third term from end. If you want to find third term from the end, first we should know how many terms are there. So, to find how many terms are there, let me take this one as the nth term. So, I am taking, let this nth term is 105, which is having a formula a plus n minus 1 d is equal to 105. This is already given to you as 10, n minus 1, common difference is 5, this is 105. When this will go to that side, I am using a traditional, the basic method. If you take it to that side, it is 95. So, n minus 1 will be written as 95 divided by 5, which is coming out to be 19. Therefore, n is 20. So, whatever arithmetic progression we are seeing here, it is having 20 terms. Now, we want to find the third term from the end. Means, the formula will be going to say the number of terms we are having 20 minus third term from the end plus 1. So, this is the term from the beginning. That means, third term from the end is actually 20 minus 3 is 17 plus 1. It is 18th term from the beginning. Means if I want to find this 18th term, that is equal to A plus n minus 1. So, this is 18 minus 1, common difference is 5. So, we are having 10 plus this is 17 into 5, which is 85. So, 85 and 10 will give you 95. So, this is one method which is known as a tradition method, in which we are going to find the third term from the end, but we are calculating from the front. Now, the best and the shortest method will be, what I will take it in the reverse order. I want to find the third term from the end. So, let me take, when I calculate from end, our first term becomes 105. Because we want to find the third term from the end, let us go to the end and let us find that term. So, this becomes A is 105. The common difference now will be negative. So, it becomes minus of 5. Clear? Because here we can say the arithmetic progression is increasing. If I see from the end side, it will be decreasing. So, that means if I want to find the third term from the end, it is very simple. A plus 3 minus 1D, which will give you 105 plus 2 times. What is the difference? It is minus 5, which is equal to 105 minus of 10, which will give you 95. So, no need to go for this long method. We can use the short technique to find the pth term from the end. Now, let us take a very important part of arithmetic progression, in which we are selecting number of terms. That means, if we want to take 3 numbers, don't worry about 2 numbers. 2 numbers can form arithmetic progression. It can form any sequence. To understand the logic, we should have 3. So, we will be first choosing that if I go with the basic format, we know arithmetic progression is generally written as A, it is A plus D, A plus 2D, A plus 3D. So, dear students, this will be the logic in which we will be going to take any number of terms for an arithmetic progression. That means, if they say that find 4 numbers in arithmetic progression, we are having the choice, we can go with this traditional pattern also. But if the sum is given, now just keep this thing in mind, when the sum is given to you, we will be adopting a new method here, in which if I want to take 3 numbers, instead of going for these 3 numbers, I should take these type of 3 numbers. Why? When the sum is given, at least we should get the answer of one of the variable in the first step. So, in that case, I will be taking A in the middle and I will take a common difference of D. It will be A minus D and A plus D. So, just see this thing. So, when we are having 3 numbers to find, that is you have to take 3 numbers in arithmetic progression when the sum is given. So, instead of taking these, I will be going to take A minus D, A and A plus D. Suppose if I want to take 4 numbers, so first I will take care of all the odd pattern. Odd pattern means for 3 numbers it is okay. If I want to take 5 numbers, I will keep A in between. Clear? And then I will be going to take D. First subtract 1 D from here, subtract 1 more D from here, and here I will be adding 1 D and again I will be adding 1 more D. So, you might be understanding that what logic is exactly going here. So, whenever we take odd number in arithmetic progression, when the sum is given to you, we will be keeping A in between and we will be moving 1 step forward, 1 step backward, 2 step forward, 2 step backward. In the same way, I can find 5 and 7 and 9, but they will not be going to get that many number of terms. So, this is the logic behind odd numbers. When we take even numbers means I will be going to take A minus D and A plus D in the middle. So, these are 2 numbers. Then, if you want to find 4 numbers means here they are having a common difference of 2D. So, subtract 2D from this, it will be A minus 3D and that side it will be A plus 3D. So, in this way we can go with 4 numbers. If you want to get 6 numbers, what you will do? I am going to have A minus D and A plus D in the middle. I will take 2 step backward, A minus 3D, and again 2 more step backward, A minus 5D. That side I will take A plus 3D and A plus 5D like that. So, this is the logic that we used to follow. Now, what we have to do? We have to first, now I will be going to take care about finding the sum of these arithmetic progression. So suppose we are having arithmetic progression with us like a plus d and a plus 2d, like that. If arithmetic progression is given to you, say up to nth term means a plus n minus 1d, then the sum of the n terms will be given by the formula n upon 2, 2a plus n minus 1d. What we have to keep it in mind, that we should have the value of n. N means the number of terms, a means the first term, and if we say d is the common difference, and of course the formula should be there with us. So Sn actually represents, it is sum of first n terms. Clear? And if I break this particular formula, I will be going to have n upon 2, this is a and a, n minus 1d. So we know that this particular format is for the nth term. So that means the formula again can be written in this way, Sn, that is sum of first n terms, is also having a logic here, n upon 2 bracket first term plus last term. So in some of the publication you may see that it will be written as L. L is actually the last term which is having the formula a plus n minus 1d. So this you can keep it in mind that whenever the numbers are given to you, say first number and last number is given to you, what you will do, I will add the first and the last, divide by 2 and multiply by number of terms. So you will be going to get their sum. Now in arithmetic progression, we have already studied about the number of terms and the sum of first n terms. Now the next part that we are having, we will be going to find the mean. The meaning of mean is something which is kept in between. It may be 2, clear? It may be 2 numbers kept in between, it may be 3 numbers kept in between. So let us take first, one number is kept in between a and b. If between a and b I am keeping a and we are saying that they are in AP, then this is known as arithmetic mean. So what is arithmetic mean? Because they will be going to form an arithmetic progression. So this is a minus a, that is the common difference. It is having the same common difference with the next two terms also, the b minus capital A. So this becomes 2 times capital A is equal to a plus b. So what is a? It is a plus b divided by 2. So this is a formula for finding the single arithmetic mean between two numbers a and b. Now after inserting one number between a and b, that is getting a single arithmetic mean between a and b, that was being taken as capital A, the arithmetic mean, which is a plus b divided by 2. Now let's insert many numbers. Many numbers means I am going to insert n numbers between a and b. Now if between a and b I am inserting a1 and then a2 and so on up to an. So what you will see that here again you have to either remember the formula or you can remember the concept. The concept behind is we are having n number of terms which is being inserted between a and b, and overall if I see there will be n plus 2 terms. Clear? So what you can say here, we know that this is actually n plus 2 terms. So b is having the position n plus 2, which is b. If I expand it as a formula, it is a plus n plus 2 minus 1 common difference is equal to b. This becomes a I will take it to that side, it becomes n plus 1 into d is equal to b minus a. So d, that is the new common difference that we are having, is n plus 1. Means what will be the common difference that we can remember? That is, take the difference of the two number divided by number of terms inserted plus 1. It is 1 more than number of terms are inserted. Say for example, if 10 terms are inserted, if 10 numbers are inserted between two numbers, what do you have to do? I will be taking the difference of the two numbers and divided by 11. So when 10 numbers are inserted, I will divide by 11. When n numbers are inserted, we will divide by n plus 1. So we are having the common difference. Means now that common difference will be added to a to get this one, again to this. So using this d, that is the common difference, we can find the next arithmetic means which are being inserted. So get that first arithmetic mean, what we will do, to that a I will be going to add this d. That means b minus a divided by n plus 1 is added, and subsequently we will be going to get all the remaining arithmetic means using this common difference. This common difference is difference of the first and the last number divided by one more than the number of terms inserted. Now, after inserting an arithmetic means between A and B, there is a specific result in which we have to find the sum of those n arithmetic means. It will be a direct question in your examination in which they will be going to ask you what is the sum of 10 arithmetic means which are inserted between the two. So, no need to find those 10 arithmetic means. We can find their sum which is having a direct result, that is it will be n times the single arithmetic means. So, between A and B, if A is inserted, the single arithmetic mean is A plus B divided by 2. This is single arithmetic mean. And between A and B, if A1, A2 and so on up to AN is inserted, the sum of these means A1 plus A2 plus so on plus AN will be equal to n times single arithmetic mean. So, that is A plus B divided by 2. It is a very important result for you to have the short method in going for the questions which are going to come in the examination. Now, after understanding all the basic format of arithmetic progression, that is the nth term, the sum of n terms of an arithmetic progression and the arithmetic mean, let us take few important properties that we can use while doing the questions of arithmetic progression. So, the first one that we can see, if we are having A1, A2, A3 as they are given in AP, arithmetic progression is there, and then whose common difference is D, then there are few things that we can keep in mind directly. That means, first of all, to these arithmetic progression, that is in this arithmetic progression, the terms of arithmetic progression, if we are adding a fixed number, if k is added to all the numbers, let us say if I am giving 2 to every number, then still they will be going to form an AP. Clear? That means when we are adding k to these numbers, it will again keep it as an arithmetic progression. The other way is, if I subtract the k, that means we are adding minus k, we can say in that way also. If I subtract k from it, k can be any constant, it can be 2, 3, 5, 10, whatever number you are having. If you subtract the same number from these terms, still they will be going to form an AP. In the same way, the second one says, when these numbers are being multiplied by some number, say if I am doubling that one, means if I am multiplying 2 to each term, still they will be going to form an AP. So, it will remain as an AP only whenever k is multiplied. And the third important part is, to these numbers if I divide by k, that means if k is say 3, so I am dividing by 3 each term, you will be going to find it will again form an AP. Say for example, if I am having 8 plus 4 I am having 12 plus 4 I am having 16 plus 4 I will go to 20. So, the logic, the first one that is saying, if I add 1 to this, so adding 1 will give you, say if I am adding 1 or 2, whatever you say, let us choose 1. If I am adding 1 to this, it becomes 9, this becomes 13, this becomes 17, that becomes 21. Again you will see that they are forming an AP. What we are getting? We are having same common difference. The common difference will not change. And if I subtract 1 from this, say now I am subtracting 2. So, from 8 if I subtract 2 we will get 6, subtract 2 we will get 10, subtract 2 we will get 14, subtract 2 from this we will get 18. Again you will see the common difference is again 4. There is no change in the common difference. And on the other way, if I multiply by 2, suppose if I am multiplying by 2, this is becoming 16, this becomes 24. When we multiply by 2, this becomes 32, this becomes 40. But here if we see the common difference, that will be k times, means if you just subtract this one, you can see 24 minus 16 will give you 8, and 8 is double of d, means 2 times of 4, that is 8. So, that is what it is written. When we are multiplying, the common difference will also multiply by k. And in the same way, when divide, let us divide by 2. So, we will get here how much? We are getting 4 divide by 2, 6 divide by 2, 8 divide by 2, 10. What is the common difference? Common difference is 2. 2 means 4 divided by 2. So, few things that you have to keep it in mind. Whenever you are adding or subtracting, common difference will remain the same. Whenever we are multiplying by a constant, d will also multiply by the constant, and if you are dividing by a constant, the common difference will also divide by the constant. Let's take one interesting fact of arithmetic progression. If I choose an arithmetic progression, let us take here 4 and I am adding 3 to this, so that we will get the clarification ki I am not choosing a specific arithmetic progression. You can also do any of the arithmetic progression. I am selecting that 4 is the first term and adding 3 to this one. So, I am getting here 7, then plus 3, it is plus 3 and again plus 3, again plus 3 and again plus 3 and again plus 3. Let us say this is coming up to 25. So, we can see that the common difference we are using it as 3. So, the interesting part is take the second term from the beginning and second term from the end. So, we can say it is 7 and 22. What is the sum? I do not know. If you take the third term from the beginning and third term from the end, it is 10 and 19. What is the sum? Don't know. If you take the fourth term from the beginning and fourth term from the end, you will get 13 and 16. I might be saying I don't know, but we know that it is coming 29, it is coming 29, it is coming 29. This is the amazing fact about arithmetic progression. And what is the sum of the first and last one? You can see the first and last one is becoming 4 and 25, which is again 29. So, the interesting part is the sum of the term of an AP equidistant from the beginning and from the end is always equal to the sum of first and last term, and this was the property that is used to find the sum of n terms of an arithmetic progression. So, next important property that we are having is, if number of terms of an arithmetic progression is odd, then the sum of the term is equal to product of the middle term and the number of terms. It is very important property. That means if you are having odd numbers, say for example, if I am having 2, I am adding 2 to this, 4, 6, 8 and 10. We want to find the sum of the terms. And what will be the sum of the terms? It is clearly written, the sum of the term is equal to product of the middle term. Middle term is 6 and the number of terms. How many terms are there? 5. So, we are having direct result 30. So, no need to count it. We can see that this is also becoming 10, this is also becoming 10, this is 10. So, we are having the sum actually equal to 30. So, what is, so this is a very important property whenever we are having odd number of terms. How to find the sum of all the terms? It is the product of the middle term and number of terms. So, this is very important property as far as your calculations are concerned. So, if you see the next one is when number of terms of an arithmetic progression is even. So, for odd we know, but when it is an even number of terms, what we have to take? Then the arithmetic mean of the middle two terms. So, we know that when we are having 4, so these two are middle. When we are having 6, so these two are the middle one. So, we have to take the arithmetic mean of the middle two terms of the first and the last term. Means if I take 2, 4, 6, 8, 10 and 12. Then what we have to find? Now what will be there? What is the middle term? So middle term you can see we are having 6 and 8. So 6 and 8 I will be going to take 6 plus 8 divided by 2, which is 14 divided by 2, which is coming out to be 7. That is, the number of terms is even. Then arithmetic mean of the middle term is arithmetic mean of the first and the last. If you take the first and the last, you can see 2 and 12. So, when you take the arithmetic mean of this one, that will also comes out to be same. So, this is also coming 7, this is also coming 7. So, whenever you want to find the arithmetic mean of even number of terms, so you have to take middle two terms, take the arithmetic mean of that, or you take the first and last term, you find out the arithmetic mean between them. Now, this is again one of the important property that you can keep it in mind. And the last one, so after this, the last one is the number of terms of an arithmetic progression is odd, then the middle term is equal to the first and the last term. That means 2, 4, 6, 8, 10, 11, 12 and I am taking 14. So, we are having again how many terms? So, we are having 1, 2, 3, 4, 5, 6, 7 terms. So we are having odd number of terms and we want to find the arithmetic mean. Arithmetic mean means it is coming how much? 8. This is the middle term. So what you can say about the middle term? The middle term, as it is been given, it is the first term and the last term. You have to take the arithmetic mean. So 2 and 14. If you add them and you take the arithmetic mean, this is coming out to be 16 upon 2, which is 8. So that means the middle term is actually the arithmetic mean of the first and the last term. So this is an important property. So these three properties can come directly into your examination. So now we are having one more important property. That means if three numbers are there which are forming an AP, so double of the middle number is equal to sum of the first and the last. The property is written there, 2b is equal to a plus c. But suppose if I take say 7 and 11, what is sum of 7 and 11? It is 18 and 18 is a double of 9. So if this type of result is coming in front of you, you can directly predict that 7, 9 and 11 they will be forming an AP. So when can three numbers form an AP? When sum of the two is equal to double of the third. So we can say that the first, second, third, they are arranged in proper format. That means here I am saying that sum of the two numbers is actually double of the third, then the first, third and the second number. That means here I am using 7, 9 and 11. They will form an arithmetic progression. In the same way, whenever three terms are there to you, that means if you take any three terms, if I go with the simple arithmetic progression, say for example, 3, 6, 9, 12, 15, 18, 21, like that. If you take any three terms, any consecutive three terms, I am taking 9, 12 and 15. So if you take any three consecutive terms, again the first and the last term, if I take the sum of 9 and 15, how much is this? This is equal to 24. It is nothing but double of the middle one. So it is 2 times 12. So important property is not only for three numbers, it can be for three consecutive terms of an arithmetic progression also. So now here again it is written as a tip. Tip means they are going to come as a direct question for you also. That means we might have seen there are many questions which if you take the previous year paper, you can see the questions are like that. So it is 7 times the 7th term is equal to 8 times the 8th term. So 7 and 8 actually they are forming 7 plus 8, we go for 15. So 15 term will be 0. So that is again a property, it's like a theorem also. That means P times pth term and Q times qth term, then P plus qth term will always be 0. And if you want to check the reason behind that, that means if it is given that 7 times the 7th term is equal to 8 times the 8th term. So what is the logic behind that? It is 7, a plus 6d, this is 8, a plus 7d. If you just see these numbers, it is 7a, it becomes 42d, that becomes 8a, and this is 56d. When you shift the terms on one side on the other, if I take everything to that side, it becomes 8a minus 7a, it is only a. 56d minus 42, it will be 8 and 6, 14. Clear? This is equal to 0. Okay, done. Now what they are saying, 7 and 8 means 15. So they are asking you to find the 15th term. So dear student, 15th term will become automatically 0, because if I expand using the formula of n term, it will be written as a plus 15 minus 1, 14d, which we have already obtained as 0. So this is an important result that you can keep it in mind. P times pth term is equal to Q times qth term, means P plus qth term will be 0. In the same way, when we are having one more question is there, that is, these are the questions that is being taken as a theorem here, as you can say a tip also, that is pth term is Q and qth term is P, then also P plus qth term will be 0. That means here if I say same thing, 7th term is 8 and 8th term is 7. Then what about 15th term? Okay, I will go with this 7th term, it is a plus 6d. What about 8th term? It is a plus 7d. When you solve these two terms, minus, 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 this is going to get cancelled, this is 1, this is coming minus d. So d is minus 1. Okay, so we are getting d as minus 1. And what about a? If you take the first line, there it is A plus 6 times D, which is minus 1, it is equal to 8. So, what is A? This is minus 6, it will go to that side, it is 8 minus 6, that is equal to 14. So, A is 14 and D is coming minus 1. Let me check P plus Q means 7 plus 8, yani 15th term. If I find that 15th term, it will be A plus 14D. What we were getting for A? 8 was coming 14. Then this is 14 times D is minus 1. So, we can say this is also coming 0. So, this is an important part, that P plus Q term will be 0, and one more thing, the nth term can be directly written as P plus Q minus N.